Hey everyone, here's a thought to kick off your day. The iron in your blood, the calcium in your bones, the oxygen you breathe, it all came from stars. Exploding stars, colliding dead stars, galaxies smashing into each other. You are literally made of recycled atoms that have been on a 13.8 billion year cosmic road trip. So in this video, we're going to dive deep into how the universe recycles itself. From the nuclear furnaces of stars to the ashes of their deaths, from galactic mergers to the formation of newborn stars, and how, in the end, that all leads to you. This is the full story of cosmic cannibalism, star nurseries, and the immortal atoms in you. Let's begin. At the very beginning, the universe was simple. A hot, expanding soup of hydrogen and helium from the Big Bang, but nearly everything else, carbon, oxygen, nitrogen, iron, gold, had to be forged later, inside stars. Stars are natural fusion reactors. In their cores, lighter elements are fused into heavier ones, releasing the energy that powers the star. But what elements a star can produce depends entirely on its mass. Smaller stars, like our Sun, have a long, steady life, about 10 billion years on the main sequence. Right now, our Sun is about halfway through its hydrogen burning phase, fusing hydrogen into helium. Eventually, it'll run out of hydrogen in the core, expand into a red giant, and start fusing helium into carbon and oxygen. But it stops there. A star like the Sun never gets hot enough to fuse elements beyond carbon and oxygen. Once that fuel's gone, it sheds its outer layers, forming a glowing planetary nebula. What's left behind is a white dwarf, a dense, hot core made mostly of carbon and oxygen. Now, compare that to a star like Betelgeuse, a red supergiant with about 20 times the Sun's mass. It lives fast and dies young. In just about 8 million years, Betelgeuse has burned through its hydrogen and helium. It's now likely fusing carbon and will move on to oxygen, neon, magnesium, silicon, all the way up to iron. This happens in onion-like layers, but once iron builds up in the core, the star's in trouble. Iron doesn't release energy when fused, so fusion stops and gravity wins. The star collapses in on itself and then violently rebounds in a core collapse supernova, flinging its newly forged elements into space. That supernova, and others like it, are key to enriching the universe with elements beyond iron. They're how we get the heavy stuff. When stars die, they don't go quietly. They seed the cosmos with their elements, and in some cases create entirely new ones. There are two major processes here, supernovae and kilonovae. Let's start with core collapse supernovae, which happen when massive stars run out of fusible material. Once a star's iron core gets too heavy, it collapses under its own gravity and rebounds in a massive explosion. This supernova doesn't just scatter existing elements, it forges new ones, especially those heavier than iron. That happens via the R process, rapid neutron capture, where intense bursts of neutrons slam into atomic nuclei, building up heavier and heavier elements in milliseconds. Elements like cobalt, nickel, copper, zinc, selenium, all born in this moment. Cassiopeia A is a stunning example. It's a supernova remnant that shows us, in high-energy X-rays, the layers of silicon, sulfur, calcium, and iron flung outward. Proof that supernova are element factories. Then there's the type Ia supernova, a white dwarf detonating after accreting too much material from a companion star. The whole white dwarf basically fuses into heavy elements, releasing iron, nickel, and more. These explosions are a major source of iron in galaxies. And then we have neutron star mergers, or kilonovae. When two neutron stars, remnants of past supernovae, spiral together and collide, they release immense energy and eject neutron-rich debris. That's where the real heavyweights get made: gold, platinum, uranium. We saw this in 2017. The LIGO observatory picked up gravitational waves from a neutron star collision. Then telescopes, including Hubble, captured the light of the resulting kilonova. Its spectra revealed freshly forged heavy elements. That event alone likely produced hundreds of Earth masses worth of gold and platinum. Think about that. One cosmic collision can seed the galaxy with treasure. Recycling doesn't stop at stars. Galaxies grow and evolve by consuming other galaxies. It's called galactic cannibalism, and it's happening right now. The Milky Way is currently cannibalizing the Sagittarius dwarf galaxy. Tidal forces from our galaxy are tearing Sagittarius apart, creating stellar streams that wrap around us. The Gaia Space Observatory has mapped these trails, showing how stars from one galaxy are being folded into another, and this has happened before. The Gaia-Enceladus merger, about 8 to 10 billion years ago, added a huge population of stars to the Milky Way's halo. Some estimates say half the halo stars come from that single event. Looking ahead, the Milky Way will collide with Andromeda in about 4 billion years. Thanks to Hubble's measurements, we know Andromeda is moving toward us. The two galaxies will pass through each other, fling stars around in tidal waves, and eventually merge into a single elliptical galaxy, Milkomeda. Simulations show that while most stars won't collide, the gas clouds in both galaxies will. Those collisions will trigger an intense burst of star formation. New stars, new planets, all from recycled galactic material. When stars die, their remains, gas and dust, become the seeds for new stars. Take nebulae like the Orion Nebula. It's a massive glowing cloud where thousands of stars are forming. Inside, you'll find everything from dense pillars harboring protostars to protoplanetary disks where future solar systems are taking shape. Hubble has imaged over 3,000 stars in Orion, from massive hot O-type stars to brown dwarfs. This region shows star formation in action. Then there's the pillars of creation in the Eagle Nebula, towering columns of gas sculpted by the radiation of nearby young stars. Inside those pillars are protostars, still forming from compressed gas. Even supernova remnants play a role. As their gases cool, they mix into the interstellar medium. Shockwaves from a supernova can trigger star formation in nearby clouds, a process called triggered star formation. In fact, some evidence suggests that a supernova shockwave may have helped trigger the formation of our own sun, so it's all connected. Stars die, and their debris becomes the birthplace of the next generation. Now let's bring it home. The human body is made of atoms that were forged in stars. By mass, you are mostly oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. With the exception of hydrogen, all of these elements were made in stars. Oxygen, from massive stars during helium fusion. Carbon, from red giants and massive stars alike. Nitrogen, forged in the CNO cycle and supernovae. Calcium, made in the later stages of massive stars. Iron, forged in supernovae. It's in your blood. Even the gold in your wedding ring. That came from a neutron star collision. These atoms took an epic journey, formed in stars, scattered across space, swept into the molecular cloud that became the solar system, locked into Earth's crust, and eventually into you. Your body is a temporary arrangement of ancient atoms. So what happens next? In 5 to 7 billion years, the sun will become a red giant. Earth may be engulfed or scorched beyond recognition. The atoms that make up you and everything around you will be vaporized, and eventually ejected into space as part of the sun's planetary nebula. And from that dust and gas, new stars and planets may form. Your atoms, your carbon, your oxygen, your iron could be part of a new world, maybe even a new life form, billions of years from now. Atoms are essentially immortal. Barring nuclear reactions or falling into a black hole, they persist. The cosmic cycle will continue. Slower maybe, but not stopped. So, here's the deeper meaning. We are not just observers of the universe, we are products of it. We are the cosmos made conscious. The universe, after billions of years of recycling, now has a way to contemplate itself through you. You are the descendant of stars, of galaxies, of cosmic collisions and stellar explosions. And your atoms, the very ones making this thought possible, will continue long after you're gone. Maybe someday, part of you will shine in a star again. If that just blew your mind, hit that like button and share this with someone who needs a cosmic perspective today. Drop a comment. Which part of this story resonated with you the most? And don't forget to subscribe to Cosmo Pulse for more deep dives into the mysteries of the universe, because remember, you're not just in the universe, you are the universe, recycled, reborn, and now self-aware.